Hey, this is Mr. Aiden. This is pre-calculus or calculus, and we're going to be taking a look at our third video on continuity. We're going to be taking a look at continuity over an interval. Okay, so let's get to it. This will be really nice and simple. You can take a look at this function right here. This function is not continuous over all the intervals, okay? We have, our graph is going kind of from -8 all the way to +8, and you can see there are some discontinuities in here. Take a look at where we have a discontinuity. Right here at +2 at x equals +2, we have a removable discontinuity. You can see right here at x is equal to 6, we have an asymptote discontinuity as well. Okay, so where are we continuous? We're continuous from all the way from -8 all the way to 2. Okay, but not including 2. We're continuous, and why are we continuous is because the f of c, it is defined for each one of those values. The limit as x approaches c of this function will exist for everything between -8 and 2, and the limit as x approaches c of f of x is equal to each one of those points. So we are continuous. Where are we also continuous? We're continuous from 2, not including 2, so we're going to put a parentheses, all the way to 6, and from 6 all the way to 8. And so keep in mind, let's say they ask us, is it continuous from 0 all the way to 4? And no, the answer is no. Why is the answer no? It is because at x is equal to 2, we have a discontinuity. Okay. In the same way, which one of these is continuous from -6 all the way to 6? Is A continuous from -6 all the way to 6, or is B? Well, of course, A is. And why is A? Because the limit as x approaches c for of f of x is equal to f of c for every single point within that interval. This B, you can see at x is equal to 5, we have an asymptote discontinuity. Okay. Last but not least, let's say they give us the functions this way, and they say which of the functions are continuous at x is equal to -2. And so you can see, keep in mind, where are three times when we're going to be discontinuous is when we have a denominator. We could be discontinuous. It's when we have a square root or an odd radical function, or it's when we have logarithms. Okay, we know we can't have negative values in that. So you can see if we plug -2 in here, the cubed root of -2 plus 1 is the cubed root of -1. Here is the square root, or sorry, the fourth root of x plus 1, which means the fourth root of -2 plus 1, which is the fourth root of -1. And I think I misspoke earlier. I should have said even number radical functions. Even number radical functions give us discontinuities. And so you can see here, the cube root of -1 is -1. The fourth root of -1 is undefined. Okay, and if we take a look at their graphs, let's take a look at the graphs this way. This is the cube root graph. This is that x plus 1 cube rooted, and you can see it's continuous on every single point from -infinity all the way to +infinity. But let's take a look at the fourth root. You can see the fourth root, we can't have a -2 value. We are not defined at this value, therefore it is discontinuous. Take a look at the second one right here. The second one we have for all real numbers, which means we're going from -infinity all the way to +infinity. And you can see here we have a denominator. X cannot equal 0 here, but x is continuous at every single value for x squared. And you can easily see this with a graph. Let's take a look at this first function. You can see there's an asymptote discontinuity at x is equal to 0. For the other function, it is totally continuous over all intervals. So quick video on continuity over intervals, and hope this made sense. Make sure you do your self-assessment on MrAiden.com so Timmy can get back to dancing Michael Jackson. He was dancing some Thriller before I did this video, and he's going to be dancing some Billie Jean, I think, after this video. So, Billie Jean is not my lover. Right? Alright, I'm just ending this video. Thanks, guys. Bye.